Hello everyone and welcome to my presentation. I'm glad to be giving a presentation at this conference today. Before I go into the content of my presentation, I would like to briefly introduce myself. I've been working in various roles in software testing since 2003, and I've been advising clients as a freelancer since the beginning of 2023. My focus is on the following topics: test management, load and performance testing, and test automation. I joined the Robot Framework Foundation at the beginning of 2024 because I believe that the Robot Framework is a very attractive test execution tool. Most of the projects I work on involve agile teams. This means that testing activities need to be integrated into the sprint. If you have a look to the test activities according to the ISDQB, you may have to think about how to organize them in such a way that they can be processed inside the sprint. Testing activities, test design, and test implementation can be combined well if test automation is used, as the test implementation tool can only work with low-level test cases. So it is obsolete to design high-level test cases and transform them to low-level test cases. In test execution, we realize that automation is a popular way to save time and become faster. But there are two topics almost always on my mind. The first is, do I have enough time for test design? The development of test cases is often the part that takes up most time. Time could be saved in this part if test cases could be generated. And the second is, do I have enough time to maintain my test cases? We all know that the test cases from the current sprint usually run well and will pass. What about the test cases from last sprints? They may be outdated or need to be adapted due to new requirements, and changes to the interface, for example, can mean that keywords need to be adjusted so the changes are handled correctly. It is not uncommon that test automation in agile projects to fail at precisely this point, and for test cases to be added to the pile of technical debt. In my presentation, I would like to show an approach that I used to optimize the test work in the sprints and thus also keep the maintenance of the test cases under control. One design method I believe is well suited to complex business rules is testing with decision tables. In the first part of the presentation, I would like to share my view of a decision table with you. In the second part, I will give an insight into how the decision table is prepared in order to be able to generate test cases. Afterwards, we then look at the test cases that result from the decision table. At the end, I will then summarize the presentation with the essential statements. So you might ask, why do I like to use decision tables? Well, I heard about decision tables for the first time in the Certified Tester Foundation Level seminar. I immediately liked the presentation and the possibility of developing test cases. The number of rules represents the number of test cases that need to be developed and executed. This metric is particularly interesting in the role of the test manager, as the test effort can easily be determined as a product of the number of rules and a standard factor for each test case. Usually, you have this when you're long enough on the project. In projects where decision tables are used in the requirement process, as a tester, I can use a simple formula to determine whether all combinations are covered or not. In practice, the decision table is very often incomplete and rules are missing. Well, this happens very often because the experts think that this particular rule cannot occur in practice, so they do not put it into the decision table. Another argument could be that the experts are not clear how should the system react, for example, with error handling. And from my point of view, it is very important that we also describe the error handling in decision tables completely, because this helps the developer most. Of course, I know the question of which tool should be used to develop the decision table. Those of you who work with common spreadsheet editors will soon realize that the decision tables quickly become very extensive. At the latest, when the decision table with all the rules does not fit on the screen, you lose track and often interest. And this was my experience as well. For this reason, I was glad that I became aware of LFET, a software from the LawThink company, a few years ago. LFET is essentially an editor that can be used to develop decision tables. In contrast to a spreadsheet editor, LFET can help you much more. For example, you can filter rules so that you have an overview and you can focus your thought to a special set of rules. Of course, LFET is able to find missing constellations, and they can be identified very quickly. But they can also give you the constellation, but LFET is not aware of how should be the behavior of the system. This must be given by you. And when you have all the rules in your table, you know from the seminar that you can also summarize rules when they are equal in some way. And this is also a feature where LFET might help you, and you can compactify your decision table as good as you can. So that we can look at low-level test cases later, I would like to introduce the example I will be working with in this presentation. This is a screenshot of LFET. In our application, we want to force the user to use a strong password. And the rule set is given in this decision table. A strong password should be 8 to 20 characters long. We assume that minimum 2 different lower cases should be included, and we want also the user to have 2 different capital letters inside the password, and he can choose whether 2 different digits or 2 different special characters. And in our decision table, you can see that rule 5 and 6 represents a constellation which is accepted as a strong password. All the other rules will describe that it violates the requirements, and the application should respond an error message. In our case, we will see later, we assume that we have got a small microservice which we hand over the password, and we get a response, an error message, or a positive message if everything is correct in case rule 5 and 6. Before we can start with the preparation of our test cases, we have to think about a little bit what should the test case for the application look like. And the basic idea is we have 2 steps. The first test step is a password must be transferred to the application. For example, in rule 1, we will transfer a password which has less than 8 characters, and we expect that the service will return an error message because the length has to be minimum 8 characters. And we check if the expected result is like this. And when we talk about the rule 1, we have already identified the main ideas. So in a decision table, conditions are usually the input of the test system or describe how the input has to be. Sometimes we have got several conditions which consider together in order to determine a special value. In our example, we have got 5 conditions which must fulfill the parameter. The actions are usually represent the expected behavior of the test system. Test instructions behind condition and action values can be more than one call of a keyword, which in the case of Robot Framework are to be provided in the form of libraries or resource files. And we can see that we are now thinking in terms of conditions and action values rather than the rules, because the rule is just a combination of different action and condition values. If we store the test instructions in the appropriate places, then the generator only has to process rule by rule, and the test case is a list of test instructions defined for specific condition and action values. For each condition or action value, I can store different items in the decision table. First of all, the precondition. You might imagine that a rule with a special condition value should need a special precondition, for example, a login or something like this. So you can store the precondition, and every or all preconditions of one rule will be generated in a special keyword and will be the test setup of this test case. The second and the third is the test instruction and the expected result. The test instruction usually is what the tester has to do, and the expected result is what the tester has to check inside a test step. If we are working with test automation tools, I suggest that you only use test instruction or expected results. In my case, I prefer test instruction because when we talk about Robot Framework, we have got a keyword-based tool, and the result will be a list of keywords, and it doesn't matter whether it is a test instruction or expected result. And in the end, you will use keywords which has got good names, and if you have got a should be or something like this, then it is a check, and otherwise it is, for example, an instruction. And finally, you can also store post conditions. With post conditions, will be handled in the same way like the preconditions. You can add something what has to be done after the test case is run, and all keywords from all action or condition values will be generated in a special keyword as well. And this keyword will be called as the test teardown in your test case. In our case, it is a little bit complicated because our validate password, where we hand over the password, doesn't really fit to only one condition. It needs five conditions cover the requirements for our password. So in this case, we can use a central element, which is the intermediate step. The intermediate step in LFET, it could be understood as a test step which is between the condition block and the actions block. And the intermediate step is generated in each rule, so we can bring it in there. So now it's time to jump into LFET, where we can store our test instructions. And we start with our intermediate step. And here we have got our keyword, which is validate password. And we will see how to figure out the correct password. So in the first step, I would like to write down a to-do. That's it. And of course, we need a second keyword where we check the response code. But here we can see that we have got much more action values, and each action value needs a test instruction. So I start with the first one. And here I've got also the possibility to bring in a test instruction. And here we expect that the password is too short. So the response should contain the code. And the code is like the symbol we use here. So it should be len less than 8. So this is our instruction, which we store right here. We have to do this for all the other error messages as well. And the additional thing we have to do is in our fifth action, we want that the password is correct. And in our case, we will not get an error code in this case. We just get no message. Unfortunately, there is a keyword for this because we can use a keyword which is called response code could be equal. We can fill it right in here. We can say the response code count should be 0, because we expect that there is no should be equal. There is no error code in our answer. In order for Robot Framework to find the keywords when executing the test cases, we need to include them. In a Robot Framework file, you know that this is done in the settings area. In the precondition of our decision table, we can add special commands which will compile the settings area in our generate robot file. So if you want to fill instructions into the robot settings area, you have to use a keyword which is star robot settings. And when you fill in the keyword resource, and we have got now our keyword file included, then we have got our statement to bind our resource file. We would actually be finished now, but we have entered a fixed password with to do. That is now used for every test case. This cannot work. The passwords required for each individual test case must fulfill between 1 and 5 conditions. LFET can use CSV files as test data. I can filter the test data using simple statements. For me, as a test analyst, this means that I have essentially to learn 3 things. First, what does a CSV file that can be used by LFET look like? Second, the test instruction for the condition and action values can be enriched with simple filter statements. And I have to insert a stub in the test statement where a concrete value is to be placed later on. Let's have a look to a CSV file for our example. In the first line of the CSV file, you can see the name, which the test data can be accessed later. In line 3, you see the headings for the individual columns. The column names are important so that a specific value can be addressed in conjunction with the name of the table. Since I only have simple comparison functions in LFET, I have defined the additional columns next to the password, which provide information about the number of different upper and lowercase letters, digits, and special characters in the password. Now I can store the filter instructions for the condition values in the decision table. I will use the password length as an example to illustrate this. The condition value less than 8 stands for a password with less than 8 characters. The filter instruction is made in 4 parts. The keyword table is used to signal LFET that the result should be a record set. Alternatively, you can use row, which means the record set should be reduced to one single data record. This is not the right one here because we will use more filter statements and we have to filter down until we get the right password. The second position is the name for the record set, which can be named freely, but you are not allowed to use those names which are already in the tables. And what I do is I use plural form in my files. So you have seen passwords. And when I filter the first time, I filter into a record set and name it in a singular form. This helps me to understand whether I have filtered once or it is an additional filtering. So I use password for the record set. And I have to filter from my passwords, which is the table inside the file. And the fourth path is I can say the length should be less than 8. And this is my filter statement. And I have to add the filter statements for all the other condition values. But I think you can understand how to do this, and I have prepared it in the beginning inside my decision table. What we can do now is we can replace our to-do. So we go into our intermediate step, and here we can place a stub to say LFET that we want to see here a result from our table. So we use curly braces, and we use an asterisk DTD for global test data, and the name of the table is password, and the name of the column is also password. So this is what we need to filter a single password from our table. And even if the generator will find more than one record in the record set, LFET will randomly choose one data set, and internally LFET will remember, okay, this data set, this data was already used, and in further test cases from this decision table, LFET will try to use a test data set which was not used in the test cases before. So it's time to generate the test cases and look at the result. While I now trigger the generation of the test cases manually, it is of course possible to start this test via a call with corresponding parameters. This means that LFET can also be integrated into a CI/CD pipeline. Generating the test cases immediately before the test cases are executed is particularly advantageous if the test cases are to match the current data in the test environment. In this case, the CSV file can be created as an export from the test environment's databases. This results in fewer failed test cases due to invalid test data. The result is a robot file with test cases. The settings area contains information on generation and the instructions used to reference libraries or resource files. We remember that we included just one resource, which is placed here. The individual test cases can be found under the section Test Cases. The name of a test case is always the consecutive number and the name of the decision table. So in our example, it is, for example, 0001, and password check is the name of the decision table. In addition to the keywords, you see we have got two in our test case. You can also see the documentation, and in the documentation you can see which rule is represented and also which conditions were used to generate this test case. For example, here you can see our first test case is a test case which has got a password with less than 8 characters. Or, for example, our last one has rule number 7, and here we have got a password with more than 20 characters, and you can see the password is very long. Now, I can execute all the test cases here, and you can see in the console that the test cases are executed and they are passed. The result can also be seen in our result file, and you can see here easily all tests were run, and we have got 7 tests and 7 paths, and you can see the name of the test suite also in our report. So we see we generated the test cases, we can run the test cases, so we have got a robot file which is ready for execution. Oh, by the way, there is a constellation in this decision table that cannot be tested. Have anyone of you discovered it? Well, let's have a look to rule number 1. If I say I would like to have a password which has less than 8 characters, and I would like to have 2 or more different lowercase letters and 2 or more uppercase, 2 or more digits, and 2 or more special characters. In this case, we will not find any password, because here we can see we have got 2, 4, 6, 8 characters. So if we fulfill condition 2 to 5, we have 8 characters minimum, and this is a contradiction to condition 1 that we would like to have a password with less than 8 characters. This contradiction could not be recognized by LFET because LFET doesn't know that these 5 conditions depend each other. But what LFET can do for you is we see that now rules are missing, and I can check. LFET says 15 rules are missing. This means combinations, and LFET is able to add all the rules, but but LFET also compactifies the rules. So when we let him to fill them in, we see these rules are missing at the moment, and we can see that we get only the conditions, but we get not the actions, because LFET is not clever enough to know the expected behavior of our system under test. And of course, we can do this for LFET. Here we need the error message less than 8 characters. We have got less than 2 lowercase. Here we have got also less than 8, and we have got less than 2 uppercase. So here this is fine, and we have got the digits, but we have got also less than 8. Of course, this is an error message as well. Now this is our new decision table, and when we check this, then everything is nice. So LFET says everything okay. What we can do next is we just save and generate our test cases. And have a look to our generated test cases in our robot file. We can see that in our settings area, one error is documented. LFET was not able to find the password because the data set was an empty set. And when we follow the message, we have to scroll right. And there you can see first filtering was length. Afterwards, we have got 329 records left. Then low cases, another 91 records left. Go to the end. And then we look at the digits. We have still 2 records left, and then we filtered for the special characters, and there was 0 records left. So we have got an empty record set, and LFET is not able to generate our test case. And if you have a look to the test case, we can also see that this test case number 5 has got a tag which is called incomplete. So if you will have later a look to your test report, you will find out that you have got incomplete test cases, and these are those which we haven't any test data for. So it's easy to identify the issues, and it's easy to check whether it is a contradiction based on the conditions or it is missing test data in your environment. With today's presentation, I would like to convey the following key messages. Decision tables are a very good tool for documenting requirements. If I, as a tester, encounter the requirements in this form, then testing efforts can be estimated very well. You saw I can count the rules, or I can count the condition and action values to estimate the effort. Using suitable editors, I can ensure that the requirements are complete and free of contradiction. This is very important for me because I would like to have good requirements, and if the requirements are good, the developing is much more easier, the testing is much more easier, and can deliver everything in time inside our sprint. The usage of a generator reduces the effort of test design. You saw we can generate our test cases, and generating will help you to use the maintenance costs because the test cases are generated and you only have to look at the keywords. It enables the creation of low-level test cases immediately before test execution because you can integrate them into your CI/CD pipeline, and it enables the creation of low-level test cases to match the current database of the test environment. This is also important for me. If you have got, for example, different test stages with different test data inside. And test cases can be generated automated as a robot file directly. In my personal experience, I believe that the decision table is not used enough. In conjunction with LFET and keyword-based robot framework, we can generate better test cases just in time, and thus make a significant contribution to supporting our agile team. By integrating it into the CD/CD pipeline, developers get timely feedback during the sprint, and the team can ensure that the new increment is of good quality when it is delivered. Finally, I would like to thank the organizers for making the slot available for me. Many thanks also to you who listened to my presentation. I hope I was able to inspire you to see decision tables in a different light. I would like to talk to you during the breaks, which is not possible at an online conference. Sorry for that. For this reason, I'm including my contact details, and I would be delighted to talk to one or two of you. In any case, I hope you enjoy the following presentations at the Wrobocon. See you and goodbye.